Hi everyone, I wanted to do a quick tutorial on how to solve one of our problems, our chemistry problems, using Excel Solver. So I decided to use problem 3 or problem 2 of homework 7. It's the last homework that Dr. Greenfield gave us um, to solve. So it says the pH of a natural water is 8.0. A 100 milliliter sample of the water required 5 milliliters of 0.10 normal HCl to titrate it to the H2CO3 equivalence point. And so it's asking us to first calculate the alkalinity of the water in equivalents per liter and milligrams per liter as calcium carbonate, and to calculate the concentrations of total carbon in the water, H2CO3, HCO3 minus, and CO3 2 minus. Okay, so I have the following set up in Excel. You're gonna need to set something like this up. I mainly just want to explain what I did so you can set something similar up. Okay, by definition, alkalinity is equal to the equivalence per liter of strong acid required to reach the zero equivalence point. The zero equivalence point is given to us here as the H2CO3 equivalence point. Those two terms are the same thing. Zero equivalence point is the same thing as H2CO3 equivalence point. The equivalence point of the most protonated term, H2CO3. It says we needed 5 milliliters of HCl, which is our strong acid, 5 milliliters of 0.10 normal. Normal, from what I remember, is equivalence per liter. So that's the wrong one. So it's basically saying that our alkalinity is equal to the amount of HCl that we put in terms of equivalence per liter. So to calculate that amount, we can ask Excel to calculate it for us. This that I wrote here, Excel isn't really doing anything with it. I'm just using it to show you guys what I did. Basically, I took 5 milliliters, multiplied it by 0.10 equivalents per liter. That gives me equivalence, and I divide it by the total volume of my solution. I originally had 100 milliliters, but because I added 5 milliliters of titrant, then I have 105 milliliters. So I asked Excel to calculate that for me. I said I made this cell equal to 5 times 0.1 divided by 105, and that gives me equivalence per liter. Then to find that value in terms of milligrams per liter of calcium carbonate, I just multiplied by 50,000, because that's how you convert from equivalence per liter to milligrams per liter of calcium carbonate. So that answers part 1 or part A of problem 3. To answer part B, which is asking us to find the concentration of these components, I'm going to use Excel Solver. So if you watched my last tutorial or my last video, I like to write out equations just as text to remind myself of what's going on and what my known values are. So here I say that the K of water is H plus times is equal to H plus times OH minus, and that's always going to be equal to 10 to the minus 14. I can't remember if I actually use that value at all here, but I like to have it on my spreadsheets always. Ka1, that value is not given, but you can find it in the book. You can also find it online. This is a very common problem. The speciation of H2CO3, the carbonate system. So it's very common. You can find that pKa1 is equal to 6.3, pKa2 is equal to 10.3. So I say that Ka1 is equal to, by definition, and I have the wrong components here. Sorry if this is confusing. This is supposed to be HCO3 times H plus divided by H2CO3. You can imagine if we were doing this problem with sulfur instead of carbon, then you could just use HS minus here and H2 S here. So this sort of approach kind of counts towards different problems. It can be used in different problems. Again, I'm gonna have to replace this S with CO3, 2 minus. Actually, I can hit Control F and replace. I can replace any instance of S2 like that with CO3 2 minus. I hit replace all. Says it did it. Okay, and I'll replace H2S with H2CO3. Hit replace all. And HS minus with HCO3 minus. Let's see. And Windows, I don't know why it uses like a dissonant piano noise chord to tell us it did what it did. But anyways, all our values are replaced, or all our text was replaced. None of the values changed. Okay, so back to the point I was making. Ka1 is equal to HCO3 times H plus divided by the more protonated form of that, H2CO3, and that's equal to 10 to the raised to the minus 6.3 is given. To make this value come up, I just I say equal to, and then I write 10. This up arrow is raised to, open parentheses, minus 6.3. 6.3 is the given pKa value. Similarly, my Ka2 is equal to CO3 times H plus divided by the HCO3 minus. Okay, and that's equal to 10 raised to the minus 10.3. Great. I have another equation here, and don't mind the formatting. C total is equal to the sum of H2CO3, HCO3 minus, and CO3 2 minus, because C is going to be distributed among these, and it's going to vary with pH. So that's just, there's no formula there. This is actually going to be my input for my solver, and I'll explain what that means in a second. Moving on, we also have this equation, which is a mass balance. It's saying that, excuse me, it's not a mass balance, it's a charge balance. All my positive ions are equal to all my negative ions. So H plus is equal to HCO3 minus plus 2 times CO3 minus plus OH minus. Also, I used the concept of alpha values for this problem because it made my equations a little bit simpler. So H2CO3 is just alpha 0, or the times total carbon. The thing to remember about the alpha values is that alpha 0 represents the fraction of total carbon, which corresponds to H2CO3. And alpha 1 represents the fraction of total carbon that equals HCO3, and alpha 2 is equal to the fraction of total carbon that goes into CO3. So if you multiply any of these values times total carbon, that'll give you the species H2CO3, HCO3 minus, and CO3 2 minus respectively. So alpha values are just fractions. Okay, this is just my my charge balance reinstated, and basically in this case my charge will not equal 0, but my charge balance is my alkalinity. So if I take HCO3 plus 2 CO3, add OH minus to it, and subtract H plus, that's going to give me my alkalinity. And the whole point is that I want to define some sort of equation that will give me alkalinity and tell solver that that equation, the value of that equation, should be equal to this that I already found here, right? I guess I should say that again to make it more clear. I can give Excel an equation for alkalinity that depends on different variables, and I can ask solver to mess with these variables, change their values, so that my alkalinity, the value of alkalinity that was calculated through solver, is equal to the value that I already know, that I calculated at the beginning of the problem. If that's true, then I know that all my H2CO3, HCO3 minus, and CO3 values must be correct. So if this cell matches this cell, then all of these cells must be okay, because this cell has nothing to do with any of the below, right? So that's the idea. I'll match this. I'll use solver to give me a pH, or give me a pH where my components will give me an alkalinity that matches a known value that I calculated at the beginning of the problem. And I'm guessing that's why Dr. Greenfield decided to give us a two-part problem. He wants us to use part A to solve for part B. Okay, these are the equations for my alpha values. I took this from a website. Instead of saying alpha 0, they just say the fraction of H2A, so that's the most protonated form. Instead of saying alpha 1, they say the F of HA, which is the second most protonated form. And instead of saying alpha 2, they say F of A2. This is just the acid with the 2 minus, the least protonated form. It's not protonated at all. In this case, F of H2A corresponds to H2CO3, HA corresponds to HCO3 minus, and A2 corresponds to CO3 2 minus. Now I have a small table, and I'm going to line these values up so that I can build up to an alkalinity formula equation. But the first value that I'm going to have is pH. This pH is given to us in the problem statement. It says that it's 8.0. Okay, so now my H plus, so before I start, you'll notice that all the values here are dependent on H plus, Ka1, Ka2, and that my charge balance has all of those values plus OH minus and total carbon. So I need to define my alkalinity in terms of all these variables to solve this problem. So the first variable is pH. It's given. H plus is by definition 10 raised to the minus pH. OH minus, because of my Kw condition, is just equal to 10 raised to the minus 14 divided by my H plus concentration. And it's 10 to the minus 14 because pH plus pOH will always yield 14. Then alpha 0, I'm just using this formula in Excel. To do that, I type equals, and then I pick the values that I need. So I guess I'll do this one from scratch so you can see what I do, in case you've never used Excel before. Alpha 0 will be equal to H plus squared. So I'm going to open parentheses, pick my H plus value, do the little arrow up, square. So I'm squaring it. Now it needs to be divided by this denominator. So I'm going to divide it, open parentheses again, get my H plus value, square it, close parentheses, plus Ka1. So here's my Ka1 value, times H plus, again I'm drawing from this equation right here, plus Ka1 times Ka2. I'm going to close parentheses and done. Okay, similarly I define my alpha 1 and my alpha 2, which are corresponding to this equation and this equation here. H2CO3 is just alpha 0 times my total carbon, which is 1. It's not, this value isn't really 1, it's just the number that it happens to be there. I have to give Excel solver a guess. So I'm guessing that it's 1 mole, but that may or may not be the answer. Similarly, HCO3 is just alpha 1 times this number, and CO3 2 minus is alpha 2 times this number. Alkalinity, like I said before, is going to be the concentration of HCO3 minus plus 2 times the concentration of CO3 minus plus OH, all minus H, the concentration of H plus. Okay. So to do that, I'm basically just taking my HCO3 value, or you could do one of two ways. I decided to do it using the alpha value. So I took the alpha value of HCO3 minus 2 times the alpha value of CO3 minus and multiplied it by my total carbon, and then I added OH minus and subtracted H plus. That's more of a complicated way to do it. You could have simply just input these values straight up right here. It doesn't really make a difference. I could have done another, so I'm going to do it in parallel so you can see. I could have said, use this equation right here, and I'll bold it. I'm going to use that equation. I'm going to say equal to HCO3 minus plus 2 times CO3 minus plus OH minus H plus. And it gives me basically the same value. Okay, now that value, I'm gonna multiply it by 50,000 to get, that's in equivalents per liter. That's my alkalinity in equivalents per liter. I'm gonna multiply it by 50,000 to get my alkalinity in terms of milligrams per liter calcium carbonate, and that's what that value is right here. So I haven't really solved anything because this value here does not match this value here that's bolded, does not match this value here, and they need to match. For them to match, I'm going to need to guess some sort of total carbon, because that's the only variable here that can change. Everything else is fixed, right? So pH is fixed, Ka1, Ka2 is fixed, and all of my other variables depend on those variables, plus my total carbon. So my total carbon has to be the variable that needs to change. All the other ones are constant. To guess, I'm gonna make Excel guess for me using Excel solver. And Excel solver is just a guessing machine. Basically, it'll guess for you 1,000 times, as many times as necessary, until all the constraints you tell it, all the constraints you give it, are satisfied. To open up Excel solver, you have to go to File, go to Options, go to Add-ins, go to Manage Excel Add-ins, make sure that's selected, and then hit Go. Then it says Add-ins available. You want the solver add-in to be checked. Then you hit OK. So you hit OK, go to Data, and all the way to the right, you'll find Excel solver. In Mac, it's the same procedure. I just don't know. You have to go to an options menu and then find the add-ins. It's the same thing. Click on solver, and then solver asks for 3 things. Solver asks for an objective, which is what you're trying to solve for. It asks you to set the objective to a value. It could either be the maximum value, the minimum value, or the some value that you pick. And it asks you how you want to change that value. So this value that you pick here has to be dependent on this value that you pick here. So my objective is alkalinity. Sorry. My objective is alkalinity. And I wanted to set it to a value of, and I can't pick a cell, so I have to give it the number that I want. And the number I want is 0.004761905 for my calculation in part B, in part A, excuse me. How do I want to reach this answer? How do I want to match this cell to this number? By changing my total carbon. That's the unknown. That's the main unknown. So I'll pick it. There are no constraints here except nothing can be negative. Nothing here is negative. There's no such thing as a negative concentration for this problem. So I'll say that make unconstrained variables non-negative. I'll make sure that that's checked. And then I should be able to hit solve. I don't know why it took me to a different page, but let's see. Okay, I need to minimize this. Let's do it again because I can tell that it's solved correctly, but I would just want you to see it. So again, let's pretend that my initial value was 1. That was my initial guess. I'm gonna go to data, I go to solver, and I'm gonna hit solve. It's already set up, and I hit solve, and you'll see that the value in this cell has changed because solver messed with it. It changed the value. It kept changing values and putting in new values until this number equals this number. So it's like guessing. Solver doesn't really know what's going on. It's just guessing just like we would. It just guesses a lot faster and a lot better than us. So I'll keep solver solution. And again, I'll verify that this number is essentially equal to this number. Okay, I'm not sure what's happening here. Okay. Yeah, my alkalinity is equal to my alkalinity here is equal to my alkalinity here. That means that all of these values must be correct. And if all of these values are correct, then my H2CO3 value is correct, and so is my HCO3 minus and my CO3 minus. And these are the values. This is my answer right here. These are in terms of moles per liter. So yeah, that is my answer. I also added a little chart here because a good question would be to ask what is the dominant species here. The dominant species is clearly HCO3 minus. If you see here, this E represents a 10 to the minus of, so this is 9.59 times 10 to the minus 5, and this is 2.4 times 10 to the minus 5. This does not have a 10 to the minus in front of it, so this is the highest value. HCO3 is dominant over HCO3 minus and CO3 minus at a pH of 8. And that makes a lot of sense because it's this pH is right in the middle between 6.3 and 10.3. What will happen is that if your pH is less than 6.3, then your dominant species is the most protonated form. Because, let's see if I can find one. No, I can't find one. Well, point is that the most protonated form dominates in the lowest pH range. The second most protonated form, in this case HCO3, dominates in the middle range when your pH is between your pKa1 and your pKa2, because the H2CO3 has not completely dissociated into a CO3 minus, but there's also not a lot of H2CO3 left, so it's mostly HCO3. Once your pH goes above 10.3, then CO3 minus is dominant. In this case, the H pluses, the hydrogens, have been stripped away from the original H2CO3 that we started out with, and so your dominant species is CO3. Again, because we started our problem is at a pH of 8, we're in this range right here, and I'll bold it. That's where we are. So it makes sense that our answer is that HCO3 is dominant. That's how you can check that. I hope this helped you out.